commissioning plan, developing a budget and allowing for growth. Learning objectives. By completing this module, you will show understanding of the contents of API RP1FSC with respect to the need for planning, to reproduce the structure of a typical commissioning plan, and restate the activities to evaluate and select a systems completion database. You'll be able to explain when a commissioning budget should be created and state budgetary parameters in terms of project size and identify factors affecting performance. You will also be able to demonstrate knowledge of estimating norms, know where these are obtained, how they are applied, and what the limitations are. The commissioning plan. The commissioning plan is a method statement read in conjunction with the project schedule of the activities and work processes to be undertaken by the commissioning team. On projects where a specialist contractor or firm of consultants will be engaged to populate the commissioning team and perform the work until closeout, a commissioning plan will be particularly useful. In such circumstances, the owner may produce an initial release of the commissioning plan for the selected contractor or firm of consultants to further develop. The commissioning plan will become a living document which the commissioning team will use as their Bible and against which their performance will be measured by the owner. The typical structure of a commissioning plan is an outline of purpose, commissioning overview, scope of work, aims and objectives, team roles, methodology, the priority systems for initial commissioning, the commissioning system database or system commissioning file, and commissioning and system challenges. The requirement for a system commissioning plan is also shown in Table 1 of API RP1FSC. This is required during the detailed engineering phase and is shown at item J in the table. Developing a budget and allowing for growth. There's been very little information available in the public domain, so estimating the scope, schedule and budget for commissioning and startup through the phase of a project has not been easy traditionally. In my experience, there's been very limited collaboration between contractors and operators. Each may maintain their own information base, but there has been very little sharing. Consequently, the information's been in a silo. I've prepared this section of the course to give some guidelines on the way in which we will be able to estimate the scope and schedule for commissioning and startup on a project. And this part of the course is very much work in progress. What I'm going to talk about here are the elements that form the budget and how to allow for growth. I'll be able to give you some norms from recent projects, some good and some not so good. All projects vary with the type of process, the industry for the project, its location, the country in which the contract is being executed, workforce competency and management ability. However, some broad guidelines are available. For overall commissioning and startup at an onshore chemical plant, around about 3.5% of the capital budget should be assigned, with approximately 70% of that in resources and craft and 30% in chemicals and consumables. For production facilities in the onshore or offshore oil and gas industry, I am recommending that 5% of the capital budget should be assigned to commissioning and startup. Developing a budget allowing for growth, number 3. Comparing norms. Shown here on this slide are 2 tables of estimating norms from previous projects. These show the norms which would be applied to types of check sheets of various disciplines. And you can see that there are average man hours of around about 9 to 12 man hours per check sheet. Now compare this with the actual man hours from a previous project for check sheet billings of different disciplines. And we can see there is an average of 10 man hours per discipline across the range of check sheet disciplines. The actual man hours were taken from a project in Norway which was thought to be poorly performing. Poorly performing because of poor productivity in the workforce and poor management ability to control the workforce. However, we can see that the billings of approximately 10 man hours per check sheet averaged across the disciplines equates very well to the approximate 10 man hours between the two norms which we saw in the previous slide. Therefore, we can safely say that at this stage we should be looking at approximately 10 man-hours per B check sheet across the disciplines. Now this is at summary level, and in the embedded files in this section we'll be able to look in some detail at the actual man-hours that you should use across various disciplines and various check sheet types. For onshore and offshore projects, I am currently showing that system commissioning is approximately 6,250 to 8,500 man-hours per system, and this will represent between 5 and perhaps 7% of the total capital expenditure for the project. The huge variation of 6,250 plus 2,250 minus 250 can be explained in a number of factors such as types of processes, industry, geographic location, management ability, workforce productivity and workforce competency. On this slide we see the figures for a notional project. It's actually the average of 2 projects executed in Southeast Asia in a shipyard in a benign environment with excellent productivity. Providing reliable information to accurately estimate the scope and schedule is not an exact science and still a work in progress. However, averaged over an entire project, we can reliably use the information contained in the embedded files at slide 107. The average number of direct man-hours per A check sheet of all disciplines will be in the range of 2 to 8, averaging 5 man-hours. In other words, 5 man-hours plus or minus 3 man-hours. The average number of direct man-hours per B check sheet of all disciplines will be in the range of 4 to 15, averaging 10 man-hours. In other words, say 10 man-hours plus or minus 5 man-hours. The average number of direct man-hours to commission an average system as recorded on a C check sheet or commissioning procedure will be in the region of 250. Extreme caution is needed here, as we know that complex systems such as power management and gas compression can take many times longer to commission, while some systems such as utility air or potable water will take much less. Therefore, the figure of 250 man-hours is an average over the entire project. The notional project completed in Southeast Asia has actual billings for check sheets, but does not include punch list items. On this notional project, with excellent productivity, we are looking at around about 6,250 man-hours to commission one system. That is the scope of A, B and C check sheets. Now contrast this with a project completed in the former Soviet Union where there was extremely poor productivity. The productivity could have been a result of workforce competency and management inability to control the work. We don't know, but what we do know is that productivity was poor and that the actual billings on the system's completions were very high. We were looking at the region of about 12,000 man-hours per system. However, this does also include punch list items. So the scope of man-hours on the poorly performing project was included A check sheets, B check sheets and C check sheets, the commissioning procedures and the punch list items, and were yielding totals in the region of about 12,000 man-hours per system.